Okay, so last meeting, ang pinag-usapan natin ay Taylor series. Okay, we um, defined what the Taylor series is. We considered a few examples of Taylor series, and then we also discussed what Maclaurin series is. Basically, a Maclaurin series is just Taylor series, pero ang expansion is about x equals 0. Okay, so in today's meeting, ang i-discuss natin ay binomial expansion, where we will use the Maclaurin expansion. Okay. Tulad ng Taylor series or Maclaurin series, yung binomial series or binomial expansion has a lot of applications in physics, okay, as you will see in the examples that we will discuss later. Okay, so binomial expansion. Okay, so basically we have a function that has this form, 1 plus x raised to the m, okay, where m is power of 1 plus x, and it's something that we need to determine later on. Okay, pag tinest natin yung convergence. Okay, so let's try to obtain a Maclaurin series expansion of this binomial or of this equation. Okay, so if you recall, okay, ang Maclaurin series, okay, is an expansion about x equals 0, so f of 0 plus x f prime of 0 plus x squared over 2 factorial f double prime at 0 plus x cubed over 3 factorial plus f third derivative at 0, and so on and so forth. Okay, so let's take the okay, so let's consider the first term, f of 0. So this f of x just simply becomes f of 0, which is 1 plus 0, or 1 to the m, or just 1, and then plus m x, okay, yung first derivative, right? Okay, first derivative ng 1 plus x to the m is m, tapos times 1 plus x to the m, pero x is evaluated at x equals 0. Okay, and then yung second derivative is, of course, m times m minus 1. Okay, and this is multiplied by x squared over 2 factorial. And if the derivative is evaluated at x equals 0, so it's just 1 plus 0 raised to the m minus 2. Okay, and then yung third derivative is m times m minus 1, m minus 2, hanggang sa multiplied by x cubed over 3 factorial, and then yung third derivative is evaluated at x equals 0, which is again 1 plus 0, okay, raised to the m, which is just 1. Okay, and so on and so forth. Okay, so meron tayong parang makikitang pattern dito, right? So if we continue this, okay, we'll end up with a term something like this, m minus 1, m minus 2, okay, hanggang sa m minus n plus 1, okay, x to the n over n factorial. Okay, so we have that term. Okay, okay, makikita nyo naman na ganyan yung case, di ba? Kasi, for example, if n is equal to 2, di ba? So, ibig sabihin, m minus 2 plus 1, okay, so that's m minus 1, which is exactly this term. Okay, so yung expression yan is consistent. Okay. Okay, so tignan natin mabuti itong coefficients na ito. Okay, ano itong mga coefficients na ito? Paano natin sila isusulat in a more compact way? So we can actually write yung coefficients na to as m times m minus 2 times m minus 1 times m minus 2 hanggang m minus m minus n plus 1. Okay, to be equal to m times m minus 1, m minus 2, so on and so forth, m minus n plus 1, m minus n, okay, then m minus n minus 1, okay, hanggang sa 3, 2, 1, all over m minus n, m minus n minus 1, hanggang sa 3 times 2 times 1. Okay, so kaya naging equal yan kasi this basically just cancels, di ba? Yeah. Okay, so equal yung left hand side dun sa right hand side. Now the numerator dun sa sa right hand side is nothing but m factorial, and yung denominator is m minus n factorial. Okay, so that's one way to write that down. Okay, so which means na pwede na natin isulat yung f of x in a more compact form. So this is the summation, okay, from n equals 0 to infinity, okay, ng yung coefficients na m factorial over m minus n factorial times x to the n over n factorial. Okay, or we write this as sum from n equals 0 to infinity ng mn x to the n. Okay, now where mn, okay, is m factorial over n factorial m minus n factorial. Okay, so now we have this binomial expansion of this equation. Okay. So of course, we need to test that for convergence. Okay. So pag may mga ganyang factorial, it's the easiest would be to use the ratio test. Okay. So again, isulat lang natin yung expression dito. Okay. Para lang maalala natin. Oops. And x to the n where m n is equal to m factorial, n factorial, m minus n factorial. Okay, so this means na ang a sub n natin is m factorial over n factorial, m minus n factorial, and ang a sub n plus 1 natin is m factorial over n plus 1 factorial, m minus n minus 1 factorial. Okay. So remember na naka-parenthesis yan. So in other words, ang ibig sabihin ganyan, n plus 1. Okay. Okay, so now we take the limit as n approaches infinity of a sub n plus 1 over a sub n. So we have the limit as n approaches infinity of m factorial all over n plus 1 factorial m minus n minus 1 factorial all over m factorial over n factorial m minus n factorial. Okay, then also this is also, sorry, nakalimutan ko yung x to the n dyan. Dito may x to the n plus 1. So this is x to the n plus 1, and this is x to the n. Okay, so this gives us, okay, of course, this cancels m factorial. And yung n plus 1 factorial, the n plus 1 factorial, okay, so ito at saka to becomes n factorial over n plus 1 factorial, okay, which gives us 1 over n plus 1. Okay, and ito at saka yan gives us m minus n factorial over m minus n minus 1 factorial, which is just m minus n. Okay, and of course, this one gives us x. So we have x times, oops, limit, of course. So we have the limit as n approaches infinity, m minus n times x all over n plus 1. Okay, so of course we can separate this as mx over n plus 1 minus limit as n approaches infinity ng nx over n plus 1. Okay, itong first limit gives us 0. Right? Okay, and ibig sabihin nito na m can be anything. Okay, kasi walang restriction na nag-arise from taking the limit, right? So this means that m can have any value. Okay? What about yung second term? Yung second term will give us, okay, this will give us a limit as n approaches infinity of x, and that should be less than 1. Okay. Of course, if we want to take yung ang tawag dito, absolute value, absolute convergence, kunin natin yung absolute value nito. Okay, so we have this and this and this. Okay. So dapat the absolute value of x is less than 1. So what about x? What about x plus 1? Okay. X equals 1. So x equals 1 is, remember that f of x is equal to 1 plus x raised to the m. So this is just 1 plus x, so 2 to the m, okay, which is a finite number. Okay, so anong mangyayari dito ngayon? Okay, so next page. So if x equals 1, then f of x is equal to 1 plus 1 raised to the m, or 2 to the m, okay, which is a finite number. Okay, and in that case, yung series natin, okay, will just be, so itong series na ito, okay, yung series na yan, x dyan will just be equal to 1, di ba? So ang matitira na lang is yung terms na ito. Okay, so kasi yung x is equal to 1. Right, so when we take the limit, when you use the ratio test and take the limit, okay, as limit as n approaches infinity of a sub n plus 1 over a sub n, then we end up with m minus n over n plus 1. Sorry. Kunin na rin natin absolute value niyan. So we take limit as n approaches infinity of the absolute value of m minus n over n plus 1. Okay? Remember that x equals 1. So dun sa derivation natin kanina, itong x na to, okay, will just be equal to 1. Okay, so this then becomes limit as n approaches infinity ng m over n plus 1 minus limit Okay, as n approaches infinity, okay, ng n over n plus 1. Okay, sorry. In this case, we don't take the absolute. Well, pwede na rin. Yeah, pwede na rin. So, this gives us 0. Okay, this gives us 0. And this gives us 1. Okay, pero may negative sign tayo dyan. So, this is actually negative 1, which is less than 1. Okay. So, ibig sabihin nagko-converge pa rin siya at x equals 1. So, meron siyang finite na series. What about at x equals negative 1? So, if x equals negative 1, then f of x is equal to 0. Okay? Which has a finite value. So, this means that the series, okay, this means that the series, or tatawagin na natin siyang binomial series. Okay, sum from n equals 0 to infinity ng mn x to the n, where mn is equal to m factorial over n factorial m minus n factorial is convergent over this interval, inclusive yung 1. Okay. So, negative 1 less than or equal to x less than or equal to 1. Okay. For all values of m. Okay. Okay. Any questions sa derivation? Okay. So, let's okay, tignan natin mabuti pa tong series na ito. Okay. There is also some restriction din. And makikita natin yung restriction na yun dito sa term na yun. Okay, ano yung restriction na yun? Okay, dapat m must be greater than n. So, the series terminates at m equals n. Okay, so actually, yung binomial series na ito, okay, so yung hindi to infinite series, so dapat ito ay titigil at m. Okay, so yun yung parang maximum value niya. Okay. Okay, so now let's consider an example. Okay, before we consider an example, bigyan nyo lang ako. Okay, so now let's consider an example. Let's consider yung isang relativistic na equation. So if you've heard of relativity theory, ito yung isa sa mga equations na ginagamit. So this describes the total relativistic energy of a particle. Energy of a particle of mass m and velocity v. Okay, so E equals m naught c squared m naught, yung mas. Okay, times 1 minus v squared over c squared, raised to the negative 1/2, where c is just the speed of light, 3 times 10 to the 8 meters per second. Okay. So we can use, tawag dito. Let's use muna, ano. Let's use yung binomial expansion in this case. So binomial expansion is the sum from n equals 0 to m ng m n, okay, x to the n. Ang m in this case, ang m in this particular example ay 1/2, negative 1/2. Okay, so we can write E is equal, oops, hindi sum, E. We can write E is equal to m naught c squared. Okay, so ang first term, let me just write out yung ano, yung binomial series dito. So 1, para lang makita natin kung ano nangyayari. 1 plus mx, diba? Plus m minus 1 x squared, right? 1 plus mx plus m times m minus 1 x squared over 2 factorial plus m minus 1 m minus 2 x cubed over 3 factorial and so on and so forth. Okay, 1. So in this case, 1 minus 1/2, okay, kasi yung m is negative 1/2 times x. Okay, plus m, this is negative 1/2, tapos negative 3/2 kasi minus 1/2 minus 1 is negative 3/2. So x squared over 2 factorial plus minus 1/2 minus 3/2 minus 5/2. So this gives us x cubed over 3 factorial and so on and so forth. Okay, so you can write m naught c squared minus, ano ba yung x dito? Ang x is, so ang m is negative 1/2 at ang x natin is v squared over c squared. Okay, and does it satisfy yung ano, yung condition? Okay, remember na ang condition is x, okay, absolute value ng x must be less than or equal to 1, which means na yung v squared over c squared, yung absolute value niyan must be less than or equal to 1. Okay, which satisfies itong condition na ito kasi yung v, velocity ng particle, is always less than c kasi yung c, speed of light, is the maximum velocity of a particle. Okay, so which means that we can use yung ano dito. Okay, yung binomial theorem. So, oops, m naught c squared, okay, minus m naught c squared times v squared c squared. Okay, and then plus 1 times 3, okay, tapos divided by 8, diba? 3/8, tapos v squared c squared squared, okay, minus 15 over 2 times 2 times 2 is 8 times 6 is 48. Oops. So 15 over 48 v squared c squared cube and so on and so forth. Okay, so ito yung ating expansion. Okay. Of course, itong term na ito, c squared cancels each other out, and syempre nakalimutan ko yung 1/2, so dapat may 1/2 dyan. Okay, so E is equal to m naught c squared okay, wait. Aha, okay, may nakalimutan ako. Sorry. Yung x is actually negative v. negative v squared c squared. Diba? So x, and remember equation is 1 plus x. Okay, so this is actually negative. Okay, so ibig sabihin plus 1 half m not v squared. Okay, itong negative sign dito doesn't matter. Okay, kasi mas square naman siya. Dito nagmamatter yung negative sign. So we have to change this to plus. Okay, and what are we going to do? Okay, so for sige, i-write out na lang natin. Sorry, nakalimutan ko din na dapat mag-multiply tayo ng m naught c squared dito at dito mag-multiply din tayo ng m naught c squared dyan. Okay, sa bawat term kasi dinistribute natin yung m naught c squared, right? Okay, sa bawat term. Okay, so this becomes plus 3/8 m naught v squared, okay, v squared over c to the fourth, okay, plus 15 over 48 m naught v squared, baliktad, v to the fourth over c squared kasi nag-cancel siya with ano, di ba? So this is v to the 6 over c to the fourth, okay, and so on and so forth. Okay, so if we factor out yung m naught v squared dito, wait, check ko lang kung tama yung ginagawa natin. So ganito na lang. Let's not confuse ourselves. So m naught c squared dyan. And this is m naught c squared din. So ito c to the fourth, and then this is c to the 6. Okay, now ang ifa-factor out natin is itong 1 half mv squared. Okay, ito. So this becomes E equals m naught c squared plus 1 half m naught v squared. Okay, first term is 1 plus 3/8. Okay, magka-cancel yung ito magiging squared, and then yung c squared dito will cancel with c the fourth dyan. So that actually becomes v squared over c squared. Tama? Okay, then factor out ulit yung v squared. So itong ito magiging 4, and then this one cancels with that one. So v to the fourth. So 15 over 48 m naught v squared over c squared raised to the raised squared, and so on and so forth. Okay, now in relativity theory, this is called the rest mass. Okay, the rest mass of a particle. Okay, and then this is the relativistic kinetic energy. Yung term na to is the relativistic kinetic energy. Now, kung titignan yung mabuti, if for speeds very much less than the speed of light, like tignan nyo yung speed of light. Ang speed of light is 3 times 10 to the 8 meters per second, or 3 times 10 to the 5 kilometers per second. Okay. Then, of course, kung gusto natin i-convert yan to kilometers per hour, so syempre, multiply natin yan by 3,600 seconds, di ba? Approximately mga 4. So that's about approximately 12 times 10 to the 8 kilometers per hour. Okay, so in kilometers per hour, yan yung ano niya, approximate na conversion. And in ordinary life, a vehicle, di ba, is just 100 kilometers per hour. Okay, 10 to the 2 kilometers per hour. So itong assumption na ito that the V is very much less than c is valid kasi you're talking about 10 squared versus 10 to the 8. And in those cases, you can ignore these terms. Okay, lahat ng higher order terms dyan ay pwede nyo ignore. And we are reduced to yung ating classical na kinetic energy, which is 1/2 m naught v squared. Okay, so yung theory of relativity actually reduces to Newtonian physics, okay, for speeds that are very, very much less than the speed of light, okay, which is, di ba, parang maganda, di ba? Kasi we have a theory, okay, that encompasses, okay, tawag dito, the older theories, right? The new theory of relativity encompasses yung older theory ng Newtonian physics. Okay? Any questions? Okay, now let's consider another example, another application. Okay. So let's try to find the series expansion of sine inverse of x. Okay, now, this is going to be tricky kasi sine inverse to ng x. And anong derivative ng sine inverse ng x, di ba? So, medyo mahirap hanapin yun. Okay? So, what we are going to do is this. So, we let y be equal to sine inverse ng x. Okay, which means na, okay, sine y is equal to x. Okay, and if we take the derivative, okay, of sine y, so let's say derivative ng sine y, okay, and derivative ng x, so we get d sine y is just cosine y. Cosine y dy is equal to dx. Tama? So which means na ang dy dx is equal to 1 over cosine y. And if we want to express that in terms of yung x, okay, so 1 over square root ng 1 minus x squared. Kasi x is equal to sine y. So, ibig sabihin 1 minus x squared square root is equal to cosine y. Okay, so now we have this equation, dy dx is equal to 1 over square root ng 1 minus x squared, okay, which we can write as dy is equal to dx over square root ng 1 minus x squared. And now we can integrate. Okay, so we'll have an expression which is y, okay, which is nothing but yung sine inverse ng x at yung hinahanap natin na at sa right-hand side, dun tayo maggagawa ng series expansion. Okay, kasi hinahanap natin yung series expansion ng sine inverse ng x, right? So to do that, first of all, we need to integrate, di ba? 0 to x, okay, ng dt over 1 minus t squared. Okay, we change the variables kasi now we're integrating. Okay, so we're integrating with respect to t, and then yung limits of integration ay with respect to x. Okay. So ano ang application ng binomial expansion dito? So yeah, i-apply natin yung binomial expansion sa 1 minus t squared raised to the square root, or 1 minus t squared raised to the minus 1/2. Okay, yun yung paggagamitan natin ng binomial expansion. So let's do that first. So 1 minus t squared raised to the negative 1/2. Okay, this gives us, okay, 1. Okay, and then yung second term natin is, remember, is plus mx. Okay, so m is, in this case, m is negative 1/2, and x is negative t squared. And remember that the absolute value of x must be less than or equal to 1, which means that t squared must be less than or equal to 1 as well. Okay. Okay, so 1 plus m, so plus negative 1 half times x, which is minus t squared. Okay, plus negative 1 half, so using m, and then m minus 1, so negative 3 halves times x squared over 2 factorial, so negative t squared squared over 2 factorial. Then plus negative 1 half, negative 3 halves, this is m, tsaka m minus 1, and then m minus 2 is negative 5 halves, and then negative t squared cube over 3 factorial, and so on and so forth. Okay, so simplifying gives us, this gives us 1 plus t squared over 2 plus 3/8 t to the fourth plus 5 over 16 t to the 6, okay, and so on and so forth. Okay, so now we have this series expansion for 1 minus t squared. So now we can go back to our original equation, sine inverse ng x, which is integral from 0 to x ng dt over square root ng 1 minus t squared. So, we can integrate with respect to x ng, with respect to t ng 1 plus t squared over 2 plus 3/8 t to the fourth plus 5 over 16 t to the 6 dt. And that's straightforward to integrate, diba? So ang first term is dt evaluated from 0 to x, so that's just x. The second term is t, right? Ang tawag dito, the second term is just, sorry, okay, x, tama. The second term is, anong integral niyan? T cube over 3, so that's, and then evaluated from 0 to x, so that gives us t, or x cube over 6, right? This term here, the third term is t to the fifth over 5, right? So 3 over 40, t to the fifth, evaluated from 0 to x, so that's 3 over 40, x to the fifth. Okay, and then the fourth term is t to the 7 over 7. Okay, so 5 over 16 times 7. Okay. Anong 16 times 7? 16, 32, 90, ano ba? 96. 96 plus 16, 100. 112. 112. Then t to the 7. Okay, and so on and so forth. Okay. So y is equal to sine inverse ng x. And now we have we have derived the series expansion of sine inverse of x. And we did that by using yung binomial series or binomial expansion. Okay. So again, let me know kung masyadong mabilis or kung meron kayong gustong balikan, may gusto kayong ipa-explain, okay, and just type it down sa chat box or just turn on your mic para masabi nyo agad. Okay, otherwise, magpo-proceed lang tayo dun sa next lesson. Okay. So, sige, let's proceed. Okay, now we started the discussion last about this Taylor series last meeting. So, and dun sa discussion na yun, we assume na yung Taylor expansion is used only for one independent variable. Okay, what happens if we use two independent variable? So let's write the Taylor series for two independent variables. And this can be particularly useful, okay, sa physics kasi um, marami sa mga equations ay dependent not just on one, but also two and sometimes three variables. Okay, so if you have a function which has two independent variables, x and y, so ang Taylor series can be written as an expansion about a and b. Okay, so expand nyo yung x at a and yung y at b. Okay, so f a b. So expand at x equals a and y equals b. Okay, so the first term of course gives us FAB, and then kunin niyo yung tawag dito, partial derivatives, okay, with respect to x and respect to y. So x minus a partial with respect to f ng x plus y minus b partial with respect to f ng y. So yan pa lang yung first derivative. Okay, now for the second derivative, we have of course 1 over 2 factorial. Okay, and then we have this x minus a squared. Okay, second derivative ng f with respect to x. Okay, tapos we also have this y minus b squared, second derivative ng f with respect to y. And then we have these cross terms. Okay, so plus 2x minus a y minus b partial with respect to x, partial with respect to y ng f. Okay? Okay, and then for the third derivative, we have 1 over 3 factorial as the coefficient. Of course, you have x minus a squared, x minus a cubed partial third derivative with respect to x ng f. Okay, plus 3 x minus a squared, y minus b, and then second derivative with respect to x, and then first derivative with respect to y ng f, plus 3 x minus a, y minus b squared, partial derivative with respect to x, and second derivative with respect to y ng f, plus y minus b cube, and then third derivative with respect to y ng f. Okay, and so on and so forth. Okay, so mapapansin nyo parang ano lang to, parang binomial coefficients lang, di ba? Dito 1, pag 2 is 1, 2, and then 1, and then 1, 3, 3, 1. Okay, so ganun lang din yung pattern. Okay, so that's that for two independent variables. Okay. Okay, so I'm going to stop sharing here. Okay, and then just show you a bit of the notes that I'm also going to send to you. Okay, so ito yung notes na ipapadala ko sa inyo. Now, towards the end, at the end of the page, or at the end of the notes, makikita nyo itong problem set or practice problems. Palitan na lang natin yun para hindi intimidating pakinggan. So, practice problems. Okay, so you have two practice problems. So you might want to work on these. Okay, if if you can find time, which I hope you can find. Okay. Yun. Again, para dun sa mga wala last time, this topic ng Taylor series is not included sa first exam. Ang first exam just covers yung infinite series, convergence ng infinite series, okay, infinite series functions, convergence ng infinite series functions. Yun na yung first exam. So itong topic na to is included dun sa second exam. Okay, but of course, you're welcome to practice on this after this meeting kasi yun naman din yung sinabi ko na habang fresh pa sa inyo, maganda na pag-practicean nyo na yun. Na meron kayong pagpa-practicean. Yan yung mga problems. Okay? Okay, let's see. So that's that for the Taylor series. Now we go to okay. And now, oops. We go to what are called elliptic integrals. Okay, so now and dito sa example na to, i-derive natin yung elliptic integrals. Okay, and we're going to use binomial expansion, okay, to derive itong mga elliptic integrals na to. Okay, and of course, towards the end, i-describe din natin kung ano yung significance ng integrals na ito. Okay, and to do that, we are going to use a physical system. At yung physical system na pag-uusapan natin is a pendulum. Okay, a simple pendulum. So let's say that we have this pendulum. So ito yung line. Okay, ito yung equilibrium line. And then we have this pendulum at this position. Although pwede nating sabihin na it started, okay, from this position. So ito yung kanyang initial position. Okay, and then ito yung position niya at any time, and position niya at x. Okay, or in this case, angular ano siya. So let's say na ito yung initial niya na position, and then ito yung position niya at any angle. Okay. The way we're going to do this is not through Newton's laws, but through energy considerations. So we have two positions here. Okay, ang unang position is yung initial position. Okay, here, if we assume that it starts from rest, so yung angular velocity niya, okay, yung angular velocity is d theta dt. Omega is equal to d theta dt will be equal to 0. Okay, then dito, meron siyang angular velocity na d theta dt. D theta evaluated at m. Okay. Okay, so d theta dt dito sa position na ito. Okay, so meron na siyang speed. So, from this position to this position, nagkaroon siya ng change in kinetic energy. Okay, and yung change in kinetic energy niya is just given by 1/2. Okay, so change in kinetic energy is 1/2 ml squared d theta squared dt. Okay, ganyan. By the way, yung L is yung length ng string. Okay, yan yung L. Okay, and of course, yung M is yung mass ng mass of the pendulum. Okay. Yan ang kinetic energy. Now, what about yung potential energy? Ang potential energy, okay, since dito siya galing, so we write that down. So minus mgl cosine theta. Yan yung final na position niya, di ba? Okay, mgl cosine theta. Okay, hindi minus pa siya. mgl cosine theta. Then subtract natin yung kinetic potential energy at this position, okay, which is mgl cosine theta m. Okay, and from conservation of energy, yung change in kinetic energy is just the negative change in potential energy. Okay? Of course, ang ibig sabihin lang nito is if kinetic energy is increasing, then the potential energy is decreasing. So we can write our equation as 1/2 ml squared d theta dt squared equal to minus mgl cosine theta sub m minus cosine theta. Okay. So ito, yun yun dyan, and then ito, yun yun dyan, with the negative sign. And now let's just isolate d theta dt. So if we do that, d theta dt becomes plus or minus 2g over L. Okay, so magka-cancel yung m, di ba? M, and then yung, m magka-cancel, and then yung 2 aangat dun sa kabila. Right? And then may L squared ka dito, malalagay L squared dyan, so magiging over L na lang yan. Okay. So 2g over L, tapos, since this is squared, okay, so ibig sabihin, magiging square root ito. Okay, that's why you have a plus or minus sign. Diba? Okay, so let's just write yung square root as raised to the 1/2. So plus or minus sign 2g over L raised to the 1/2. Okay, times cosine theta minus cosine theta sub m raised to the 1/2. Again, square root yan. Okay. And this is our working equation. Okay. So makikita nyo na ngayon kung anong paggagamitan natin ng Taylor series or ng binomial series. So we have d theta dt is equal to plus or minus 2g over L raised to the 1/2 cosine theta minus cosine theta sub m raised to the 1/2. Okay. Okay, so we are going to stop at this. Okay, so welcome back. Okay, meron kayong questions? Everything clear? Okay. Let me just go back briefly dun sa figure. So, okay, dito sa figure na ito, okay, I said na ito yung initial position, okay, but it's not actually the initial position. It could be anywhere. So let me just correct myself dyan. Oops. Ah. Ah. So this is not the initial position, okay, but this is a maximum position. Okay. Yung maximum ng height na in-achieve nung pendulum. Okay, so that's why you have the subscript m there. Okay. And at the maximum position, of course, yung kinetic energy is 0 kasi nga yung velocity or yung angular velocity at that position is 0 at the maximum. Okay, so the task, of course, is to try to obtain an expression that we can describe this simple pendulum with, diba? Ang isang expression o isang parameter na ginagamit natin dito is yung period of oscillation, diba? So we'll try to solve yung period of oscillation dito at tignan natin kung ano yung lalabas. And to do that, we'll use the binomial series. Okay. So the goal is to solve for the period. Okay, period T. Okay. Okay, now if we assume that at t equals 0, yung initial position niya is at 0. Okay, you remember na yung definition ng theta is this. So, ibig sabihin, ang initial position niya ay, okay, yung initial position niya ay nandun sa vertical line. Okay, and then it swings towards the maximum, which is theta m. Okay? So, ibig sabihin, pwede nating isulat itong equation na ito as d theta. Okay, so we can write this as d theta all over cosine theta minus cosine theta sub m ng 1/2. Okay. Saan natin lalagay yung dt? So, plus or minus, let's just use plus. Okay, anyway, we can simply insert that later. 2g, square root ng 2g over L dt. Okay? So this corresponds, itong theta m na yan yung, okay, so let's see. So if the pendulum starts here, and then it reaches this maximum value here, okay, of course it will swing back there to the other maximum value and then pabalik dito. Okay, so kung titignan natin from here to here is 1/4 of the period, right? Kasi ang isang period is the time it takes for one cycle, and the time it takes for one cycle is hanggang makabalik siya dito. So this is 1/4 going there, another 1/4 going back to the equilibrium position, another 1/4 going there, and then the last 1/4 going back to the equilibrium position. So yung period from here to here is just 1/4, okay, of the total period. Okay. So ibig sabihin, when we use the limits of integration, okay, so let's say we take the limit from 0, okay, to theta sub m ng okay, cosine theta minus cosine theta sub m ng negative 1/2 d theta equal to 2g over L 1/2 ng dt. So, at t equals 0, theta is equal to 0, and at t equals t over 4, theta, yun yung na-reach niya yung maximum value. Okay, d. Okay, so ang right-hand side will give us t over 4, 2g over L square root niya. Okay, so this means na ang period ngayon is 4 times L over 2g square root times the integral from 0 to theta sub m ng cosine okay, sige. Cosine theta minus cosine theta sub m negative 1/2 d theta. Okay? Okay. So now we're going to use a few tricks. So we know that cosine theta, okay, from trigonometry, okay, is equal to 1 minus 2 sine squared theta over 2. So in the same way, cosine theta sub m is equal to 1 minus 2 sine squared theta sub m over 2. Okay, so the period is equal to 4 times L over 2g square root 0 to theta sub m, okay, ng okay, 1 minus 2 sine squared theta over 2 minus 1 minus 2 sine squared theta sub m over 2 raised to the negative 1/2 d theta. Okay, so of course yung 1 dyan magka-cancel. Itong 1 na to tsaka itong 1 na to magka-cancel. And then itong minus sign dito at tsaka minus sign dito magiging plus. Okay, so we can reduce this to 4 L squared ng L over 2G 0 to theta sub M ng 2 sine squared. Pwede na natin actually factor out yung 2. 1 over square root of 2 yan. Sige. 1 over square root of 2. Factor out na natin siya. So 1 over square root ng 2 sine squared theta sub M over 2 minus sine squared theta over 2 ng negative 1/2 d theta. Okay? Okay, so t is equal to 4 over square root ng 2 L over 2G raised to the 1/2. Integral from 0 to theta sub M. Okay, now, okay, if factor out natin ito ngayong sine theta sub M from this whole bracket. Okay, so mangyayari is sine squared, okay, theta sub M. Okay, pero mawawala na yung ano niya. Sige lang. Ganito muna. Sine squared theta sub M over 2. 1 minus sine squared theta over 2 sine squared theta sub M over 2. Okay. And then, of course, may negative 1/2 tayo dyan, di ba? Dito, pag in-apply natin yung negative 1/2 dyan, magiging negative 1 yan. Okay, so sine negative 1. Of course, d theta. Okay. So, bakit natin ginawa sa ganitong form? Kasi to be able to use yung binomial expansion, we need to have x, absolute value of x less than or equal to 1, right? And by setting it in this way, okay, we are assured na this condition is satisfied kasi theta is less than the maximum value. Any value of theta at any point dun sa swing niya is always less than the maximum. Okay, so yung term na ito, okay, yung term na to, okay, allows us to satisfy this condition and then consequently allows us to use yung binomial expansion. Okay, now sobrang daming sobrang daming nangyayari. So, ang gawin natin, simplify natin ng konti. We let u be equal to sine theta over 2 sine theta sub m over 2. Okay, so such that itong nasa square brackets na yun will be u squared. Okay, so this means na at theta equals 0. So at t equals 0, theta equals 0, and u is also equal to 0. Okay, and then dun sa maximum value, okay, at theta equals sa maximum value, okay, u will just be equal to 1. Okay. So ginawa natin yan of course kasi papalitan natin yung limits of integration. So now we have t equal to 4 over square root of 2 okay, ano pang kailangan natin? Yung d theta, kailangan din natin palitan yung d theta pala. Okay, let's see. So du is equal to 1/2 cosine theta over 2, right? Divided by sine theta sub m over 2. Okay, so this gives us sorry, d theta. Okay, so this gives us du equal to oops, du equal to 1/2. Okay, wait. Cosine theta is 1 minus u squared. So ganito. Para hindi no? Nakakalito. Okay, let's go to the next page. So, ito yung tinatry nating i-derive. So we were writing sine theta over sine over 2. Theta m over 2. And then nakuha natin na du is equal to just 1/2 cosine theta over 2 sine theta sub m over 2. Okay. And cosine, which means na cosine from here, cosine theta over 2 is just d theta. Cosine theta over 2 is just, d theta is just, sorry. Hindi dyan, kundi galing dito. So, sine theta over 2 is equal to u sine theta sub m over 2, which means na ang cosine theta over 2, which is square root ng 1 minus sine squared theta, is 1 minus u squared sine squared theta sub m over 2, okay, square root. Okay, at yan yung ipapasok natin ngayon. Ito. So we have du. Okay, we have du equals 1/2. Tapos yung cosine theta over 2, 1 minus u squared sine squared theta over 2. Okay, and of course square root yan. Then divided by sine theta sub m over 2, and then d theta. Okay. So the period then becomes 4 times L over 2G square root. Okay, and then of course may ano tayo dyan, square root of 2. And then yung limits of integration natin nagbago from 0 to theta sub m to 0 to 1. Okay. Limits of integration is 0 to 1. Tapos meron tayong sine sine theta sub m over 2 doon. Okay, and syempre yung d theta. So mangyayari dito is sine theta sub m over 2 du all over 2 times 2 yan. Of course, 1 minus u squared sine squared theta over 2 raised to the 1/2 is equal to d theta. Okay, wala akong ginawa dyan kundi lahat nito ay nilipat ko lang sa kabilang side. Okay, so ngayon, okay, meron tayong expression for d theta. So pwede nating palitan itong expression na ito. Okay, so we have ito munang sine inverse theta sub m over 2. Sine inverse ng theta sub m over 2. And then itong 1 minus u squared. Okay. 1 minus u squared, negative 1/2. And then, meron tayong 2. Okay, na ilalagay natin somewhere. Sige, ilagay ko muna dyan, 2. Tapos, sine theta sub m over 2. Okay, all over 1 minus u squared, sine squared, theta over 2, and then square root. du. So, this cancels with this. Okay? At ang magiging expression natin for the period will then be will end up with 4 over square root of 2 L over 2G raised to the 1/2 0 to 1 ng 2 du all over 1 minus u squared sine squared theta over 2 raised to the 1/2 and then 1 minus u squared raised to the 1/2. Okay. Okay? Okay pa kayo? Okay, so konti na lang at makukuha na natin, magamit na natin yung ma-derive na natin expression for the period. Okay. Konting tawag dito, steps na lang. Okay. Now, we're going to do another change of variable. Okay, and so ang gagawin natin is we're going to define u be equal to sine phi. Okay, so ibig sabihin, since ang definition natin ng u is sine theta over 2, sine theta sub m over 2, okay, yung ratio na yan is just equal to sine phi. Okay, so this means that sine theta over 2 is just sine theta sub m over 2 sine phi. Okay, we note that if u is equal to 0, then then sine phi is equal to 0, which means the phi is equal to 0. And when u is equal to 1, sine phi, of course, is equal to 1, and then phi means that it's pi over 2. So papalitan ulit natin limits of integration. So p is equal to 4. Okay, so let's take a look at this. So may 2 tayo dyan, and then may square root of 2 tayo dito, tapos may square root of 2 din tayo dyan. Okay, so cancel lahat yan. So ang matitira is L over G square root. Then yung limits of integration from 0 to pi over 2. Okay, and then yung du is equal to sine phi cosine phi d phi. Okay. Okay, so this gives us or equal to, so square root ng 1 minus u squared, okay, d phi, okay, du, kasi yung u, yung u is equal to sine phi, so ibig sabihin cosine phi is 1 minus square root of u. 1 minus u squared square root. Okay, so du over square root ng 1 minus u squared is equal to d phi. Okay, and if we go back here, tignan nyo to, du, okay, over 1 minus u squared square root, that's exactly what d phi is. So we can write, okay, d phi sa ibabaw. And then, yung sa ilalim, yung u squared, papalitan natin yan ng sine squared phi. Yun lang ipapalit natin doon. So, 1 minus sine squared theta sub m over 2 times sine squared phi. Okay, square root. Okay, and this is what we are going to expand. Okay, so we are going to expand f of sine squared theta sub m over 2. Okay, in other words, ang i-expand natin is 1 minus sine squared theta sub m over 2 sine squared phi negative 1 half. So ang expansion natin is about sine squared theta sub m over 2. Okay, ang ibig sabihin lang yan, so we expand about sine squared theta sub m over 2. Ang ibig sabihin lang yan is, pag mag-expand kayo about sine squared theta sub m over 2, lahat ng terms na makita nyo na sine squared theta sub m over 2, okay, ay iset nyo lang to 0. Okay. Okay, so for each term. Okay. So if we do tawag dito a binomial series expansion, remember that the first term is just f of tawag dito f of 0 ang first term. Okay. So ano ang f of 0? So remember that you're evaluating sine squared theta sub m over 2. So ang f of sine squared theta sub m over 2 equal to 0. Okay. So ito ang equal to 0. What does that give us? Okay, 1 minus or 1, di ba? Kasi 0 yung second term. So this is just equal to 1. Now yung second term is ay may first derivative. So first we need to get the first derivative ng function na yan. Okay, yung derivative of course is with respect to phi. So this is negative 1 half times with respect to sine squared theta sub m over 2. So this is negative sine squared phi. Okay, so 1 minus sine squared theta sub m over 2 sine squared phi, and then negative 3 halves. Okay, and then we evaluate that for sine squared theta sub m over 2 equals 0. So pag 0 yan, so ito gagawin natin 0. Okay, so itong term na to, this reduces to just 1. Okay, and we are left with 1 half sine squared phi. Again, if we take the second derivative of sine squared theta sub m over 2, we get negative 1 half, yun yung meron kanina, and then yung negative 3 halves na bagong power niya, sine squared phi, sine to the fourth pi, kasi may dalawa na yung sine squared. So we are left with 1 minus sine squared theta sub m over 2 sine squared phi. Negative 5 halves na to. Evaluated at sine squared theta sub m over 2 equal to 0. And in that case, this is 0 and this becomes just 1. So now we are left with 3/4 sine to the fourth pi. Okay, and if we do one more, okay, hindi ko na gagawin expansion. Sulat ko na lang yung sagot. 15/8 sine to the 6 ng phi. Okay, so our Taylor series expansion about sine squared theta sub m over 2 gives us, okay, yung first term natin is 1, yung second term natin is 1 half sine squared phi, plus yung third term natin which is Okay, ito yung first derivative pero meron ka pang ano, di ba, u or dapat x. Pero ang x natin is sine squared theta m. So, ulitin ko lang. Okay, sine squared theta sub m over 2 and then sine squared phi. Okay, remember it's 1 plus mx, di ba? So ito yung x natin is this. Okay, so kaya meron pa rin tayong sine squared phi sub m over 2 dyan. Okay, and then yung next term is x squared over 2 factorial, right? So yung coefficient natin dyan is 3 over 8. Okay, pinasok ko na yung 2 factorial. Kanina 3/4 lang yan. Okay, pero nag-multiply pa ako ng 1 over 2 factorial, so naging 3/8 yan. And then sine to the fourth, okay, ng theta sub m over 2. Okay, and then sine to the fourth ng phi. Yung third term is 15 over 24. Okay, kasi dito 3 factorial naman yan. Kaya from 8 naging 24 kasi nag-multiply tayo by 6. Sine to the 6, theta sub m over 2, sine to the 6, sine 6 ng phi. Okay, and so on and so forth. Okay. So yung ating period ngayon is 4 times L over G square root evaluated from 0 to pi over 2 okay, ng 1 plus 1/2 sine squared theta sub m over 2 sine squared phi plus 3/8 sine to the fourth theta sub m over 2 sine to the fourth phi okay, plus 15 over 24 sine to the 6 theta sub m over 2 sine to the 6 phi and so on and so forth d phi. So anong natira? Ang kailangan na lang natin evaluate ay sine squared phi d phi. Integral ng sine squared phi d phi. Integral ng sine to the fourth phi d phi. Integral ng sine to the sixth phi d phi. Okay, so just using the table of integrals, okay, we have sine to the 2n theta d theta. Okay, this gives us 2n minus 1 double factorial 2n double factorial pi over 2. Okay, ang 2n double factorial is nothing but 2n times 2n minus 2 times 2n minus 4 times 2n minus 6. Okay, hanggang sa 3 hanggang sa 2. Sorry, kasi even ano yan, even numbers. And then ang 2n minus 1 factorial dito ko na lang lalagay. Double factorial is 2n minus 1 times 2n minus 3 times 2n minus 5 hanggang sa 3 times 1. So mga even, mga odd number factorials. Okay, finally, oops, we are now able, oops, we are now, or we end up with our final expression for the period, okay, to be, okay, 4 over 4 times 4 times square root ng L over G, okay, times pi over 2 after ano na to, no? After evaluating yung limits of integration. 9 pi over 128 sine to the fourth theta sub m over 2. Okay, and so on and so forth. Okay, and then we factor out pi over 2. Pag factor out natin yung pi over 2, we have 2 pi L over G square root ng 1 plus pi over 4. Okay. Sorry, wala na palang pi. Pinactor out na natin. 1/4 sine squared theta sub m over 2 plus 9/64 sine to the fourth theta sub m over 2 plus. Okay. Now, anong mapapansin natin? Okay, if sine squared theta sub m over 2 is very much less than 1, okay, itong mga terms na ito, okay, can be neglected. And then we'll end up with an expression for the period which is just 2 pi square root ng L over G. And if you recall sa 101 ninyo, yan ang expression for the period na ginagamit ninyo. Okay. So what we have here is a less tawag dito. Hindi siya more exact, pero less yung approximation kasi now we included yung maximum na na angle, okay, corresponding to the period. Okay? Okay. Now, yung ginawa natin is an exercise in using binomial expansion. Although yung talagang binomial expansion ay nandoon na sa bandang dulo, okay? We did a lot of mathematics, okay, just to be able to derive dito sa expression na ito, okay? Dito sa expression na ito. Okay, where we can expand dito. Yan, dyan sa expression na yan where we can use yung ating binomial series. Okay. But another thing about this equation is that, or this derivation is that, we've introduced what's called an elliptic integral. Okay, and what we used, okay, f of phi alpha, okay, evaluated integral from 0 to alpha. Okay, ng 1 minus sine squared phi sine squared theta is to the -1/2 d theta. Okay, looks familiar ba? Okay, this is called the elliptic integral of the first kind. Okay. So let's say na if tulad ng ginawa natin kanina, if we let t be equal to sine theta, then dt is equal to cosine theta d theta. And this is equal to, of course, 1 minus t squared d theta. Okay, and if we let m be equal to sine squared phi, okay, then yung integral na ito, okay, we can rewrite this integral in terms of x and m. So 0 to x ng 1 over 1 minus t squared raised to the 1/2. 1 minus mt squared raised to the 1/2 ng dt. Okay, okay, here m is m is equal to sine squared alpha, di ba? It's between 0 and 1, including 0. Okay, for the special case na kung saan phi is equal to pi over 2, which means na x equals 1, okay, we write it as km, okay, evaluated from 0 to pi over 2, integrated from 0 to pi over 2, and 1 over 1 minus m sine squared theta -1/2 d theta, or 0 to 1 ng 1 minus t squared 1 minus mt squared, okay, -1/2 dt. So this is called the complete elliptic integral of the first kind. Okay. Just 2 more slides, then we're done. Okay, then you also have the elliptic integral, the second kind. Okay, so E phi alpha from 0 to alpha ng 1 minus sine squared phi sine squared theta 1/2 d theta if we let t be equal to sine theta, then dt is equal to cosine theta d theta, or 1 minus t squared d theta. And again, if m is equal to sine squared alpha, then the above integral, the integral na yan becomes xm 0 to x, okay, ng 1 minus mt squared 1/2 1 minus t squared square root dt. Okay, where again sine squared alpha is between 0 and 1. Okay, okay, and for the special case, na phi is equal to pi over 2, x equals 1. Okay, we can write the equation as km 0 to pi over 2. 1 minus m sine squared theta square root d theta, or 0 to 1 ng 1 minus mt squared over 1 minus t squared square root ng dt. So this is the complete elliptic integral of the second kind. Okay, so yung mga elliptic integrals na yan, uh, have particular usefulness pagdating sa ilang mga physics concepts, like itong anong tawag dito, itong simple pendulum. Okay, let me just show you one more slide or one more thing. So ito yung itsura ng ano, no, ng mga elliptic integrals, complete elliptic integrals, so the first and second kind. Okay. So yung E sub m yung second, and yung K sub m is yung first integral. Okay, and you can get yung limits na yan by simply evaluating yung limit as tawag dito, evaluating yung limit ng K sub m as m approaches 0. Okay, so ito yung lower limit. So this is what you get. So both of them will approach pi over 2. And then yung upper, to evaluate the upper limit, you let m approaches 1. So for the first elliptic integral, it approaches infinity. But for the second elliptic integral, it approaches 1. So ganito yung itsura nung graph nila. Okay? Okay. So that's it for today. Do you have any questions?